Hello, today I'm going to show you this 3D Pythagoras example. So we have this cuboid, we've got it labelled, you can see A, B, C, D, etc. It's got a height of 4, a width of 6, and a length or a depth of 7, whichever way you want to think about it. So we're asked to find the length AH, and all we need to know for this is Pythagoras' theorem. So Pythagoras' theorem is about right angled triangles. So if I quickly jot one down the slide. What it states is basically a relationship between all of the sides. So if we label this one A, this one B, and the longer one, which we call the hypotenuse, we'll label that C. What we know is that A squared plus B squared is equal to C squared. And that's always true for a right angle triangle. So the way we're going to do this is we're trying to find the length AH. So sort of the diagonal is how you can think about it. It's the top front left, and the back right and bottom one. So yeah, the diagonal of the cuboid is how you can think about it. So we'll first off start by looking at the front surface. So this A, B, C, D little rectangle we have, and we'll draw that out quickly. Doesn't have to be to scale. It's just a quick sketch to try and give us an idea of how this surface looks, not compared to the rest of the shape. So we'll draw that out and label it and fill in any side lengths that we know as well. So A, B, C and D. And this is 4 and 6. So this is also 4 and 6 because this is a rectangle. So what we're going to do is our target is basically to go from A to H. So we can see that D is like the corresponding angle. It's the corresponding vertex on the front surface compared to the back surface. So we're going to basically find the length from A to D. So drawing a line along here. Oh, excuse me. So we'll do that by looking at this right angle triangle, the ADC right angle triangle. And what we can see is that the length AD, if we square that, is going to be equal to 4 squared plus 6 squared. So computing this, that's 16. This is 36. So that sums to 52. So altogether, the length AD is equal to the square root of 52. Beautiful. We're now then going to look at a new surface, but this isn't really a surface of the cube, but it's just a surface that we're going to imagine and sort of visualize this inside of the cube. So if I join up the AD line that we just calculated, and draw the corresponding line on the back surface, so from E to H, we can think about this new surface. It's not a real surface, but imagine if you slice this cuboid in half, you'd get this sort of rectangle inside that joins up A, E, H and D. So we'll jot that down at the bottom here. Try and keep the cuboid a little bit in the top there. So just another rectangle. Again, doesn't have to be to scale. We can almost just draw exactly the same one as before. We'll label that again, just like we did. So we've got A and E, and we'll try and think about which side's going to be longer. So the 7 is probably a little bit longer than root 52. Or no, root 52 is a little bit longer. So we'll make that this side here. So that's going to be along here. So that's A to D. And the other side then D connects to H. And H is, well, E is in between A and E, A and H. And we'll fill in the side lengths. AD was root 52. So this is root 52 as well down the bottom. And this side is 7. This is 7 from the 7 that we have on the diagram there. Beautiful. So we now have sort of both the target, the start and the end point that we're trying to find on our little rectangle here. So we're able to just draw a line here and use Pythagoras again to find this length. So we can see that AH squared is going to be equal to 7 squared plus root 52 squared. Well, square root and a square, they're the inverse of each other, so they cancel out. So what we're left with is 7 squared is 49, and this all ends up just being 52. So when we add these together, then that gives us 101, which means our final answer, the length AH, is the square root of 101. Beautiful.